Hello everyone. Today we will be discussing chapter 5 and it's all about nuclear chemistry. Yes! So nuclear chemistry basically is the branch of chemistry that actually deal with the nucleus of the elements. And so any change in the nucleus of the elements, it will cause a radioactivity process. And what's inside the nucleus? We do have protons and neutrons. So any changes in the number of neutrons or protons will cause a radioactive. What what is radioactivity? So radioactivity is basically when the nucleus of an atom change, lose or gain atom or the element lose or gain any um, different types of radiation like alpha, beta, gamma, X, protons, neutron, energy. All of these will be considered energy. So whenever this happens, we call this radioactivity, and we call the element radioactive element. Um, uh, the radioisotope. So first, let's try to remember what is an isotope. If you remember what is an isotope, like carbon 14, carbon 15, carbon 14, 15, and 16. All of these are isotopes. Hydrogen 1, hydrogen 2, hydrogen 3. All of these also are isotopes. And though the definition of an isotope is different versions of the same element with different number atomic mass number or different number of neutrons. So when this happened, we call the element radioisotope. So it's an isotope because it has different numbers of neutrons, and radio because it releases radiation or emit radiation. Um, and when we write down the isotope, we always use the mass number. So this is, for example, iodine isotope. We call it iodine 131. Um, Um, there are types of the radiations. We have alpha radiation, beta radiation, positron radiation, gamma radiations, X-ray radiations, proton radiations, neutron radiations. All of these are types of radiations. What we need to know here is the symbol for each radiation and the number of electrons and the protons. So we can say instead of alpha particles, we can actually alpha radiation, we can actually say it's the same as the helium atom with 2 electrons, 2 protons, and 2 neutrons. We can also say that the beta particle is like an electron, which means the energy, it's an energy that have basically a charge. So it's a -1. We can write electron and it's -1. Also positron, we can give it, so beta is B without any symbols, but positron is basically a beta particle but positive charge. So we can write it as well as electron E, and the mass number is 0 because it's only electron, and +1. And the pure energy is the gamma, and the gamma symbol is basically Y00. So this is the gamma. It's not Y, but it's a gamma symbol, and you can just remember it this way. And it has a 0 and the 0, 0 mass number, 0 atomic number. Proton radiation is basically one hydrogen atom with 1 electron and 1 proton. Neutron radiation, you basically will write N, And of course, at the bottom will be the atomic number. We will not write anything. It's only a neutron radiation. So we will write 1 on the top. It's very important to know these symbols and the name of each one of them, because we will do at the end of the chapter, we will be doing equations and balancing nuclear equations actually. So these are this table is basically a description of all what we were talking about, like the symbol and how to write it chemically, and what is happening with it in each atom, and then the mass number of each one, and then the charge of each one as well. So keep practicing so you can remember or memorize the symbols. The alpha and beta and gamma radiation basically are harmful for for any organism, because they basically knock away the electrons in molecules and forming unstable ions. And these unstable ions actually cause undesirable chemical reactions that can cause cancer and other diseases. The alpha usually the a paper can actually you can have a shield of a paper and can prevent the alpha. So it's very still radiation, but very long radiation, so it doesn't hurt that much. Beta is a higher in the effect, so the cloth or clothes, your clothes can help in preventing the beta. The gamma is just woo. It can even actually penetrate your nucleus, your cellular nucleus, and also can penetrate and damage your DNA. So gamma radiation is very damaging, and X radiation as well. So what prevent gamma and X radiation is concrete. That's why whenever you do imaging with X-rays, they usually put a concrete protection whatever you're doing the X-ray. Um, so there are types of nuclear reactions. We do have 4 major types, but the first one has about 8 types. So we will learn all of them. So we have radioactive decays and transmutations. We have fission and we have fusion. So fission and fusion, and radioactive decays and transmutations. So we'll go one by one. So the first one is a radioactive decay. The word can give you a hint on what's happening in this reaction. Radioactive decay. So radio from radiation. Active means it is active in radiation, so it emits radiation. Decays means breaking down um, or disappearing basically eventually. So it means that there is some kind of activity that causes the element to be broken down into other elements. So let's see what is radioactive decay. So we have many types. So we have alpha decay, beta decay, positron decay, gamma decay. We have proton decay, neutron decay. So we have many types of decays. Let's try to explain the alpha decay. So again, the alpha symbol is this one here. So this is the alpha symbol, okay? And here we do have the uranium 227 So the uranium-227 is a huge, large, unstable nucleus element, and because it's unstable, it will emit energy, which is alpha in this case, and it will produce a new, smaller, more stable element as a result. So the decay is basically you have to have a very active element that needs to turn into a stable element. And to do this, it emits radiation. And if you look carefully on this equation, so this is basically a translation, a chemical translation of what we just explained. So this means that uranium-227, so this is the mass number and this is the atomic number, and then it will emit alpha, okay, and this is alpha, 2 electrons and 2 protons and 2 neutrons, and then it will produce this element. How can we? So basically we do have this equation, and from this equation I can give you the first element, and I can tell you that this decay it is an alpha decay. Write the equation. So you will write your element that I give you. So I basically give you two hints here, the element and the radiation, and asking you to figure out this. To do this, we have a very simple base that we have to learn. Anything before the arrow has to be equal to anything after the arrow. Anything in the reactant side has to be equal to anything total on the product side. So if you add 223 plus 4, it's 227 basically. If you add 90 plus 2, it's 92. So if I give you this one and told you that it's an alpha decay, then it's very easy for you to figure out the rest. Simple math, nothing complicated here. All this chapter, nothing is complicated. It's all about just adding, subtracting, adding and subtracting. So just follow the way, and it would be very easy to practice on doing this. So this is alpha decay. And this is how it looks like. You can see this is a big element. This is another uranium actually. This is uranium-238, and it also emits alpha, and also produce another Te isotope that's called 234 element. And this is alpha particle, and this is a new element. This is another example. So CF, and this is 251 mass number and 98 atomic number. And here is clear that it emits alpha. So let's try to do this from scratch so we know how to do that. So CF251. So it's CF251. Okay. And I told you it's alpha decay, which means you will have alpha, and this is a symbol. Okay. Find the new element. And let's get the atomic numbers as well. 98. Okay, there you go. How to do this? Again, anything in the reactant side has to be equal to the total of the product side. So basically what we're saying is 251 is equal to 4 plus what? Find this. So 251 minus 4 is your result. And here we have 98 equal what? Plus 2. Same thing. So 98 98 minus